Okay, hello everyone. So here, this is going to be the first of two sections involving two very important theorems involving sine. One involves sines and one involves cosines. And you're going to be, this is going to be kind of like some generalizations of the Pythagorean theorem. Because most triangles that we work with are not right triangles. Okay, they're oblique triangles. Okay, oblique is just triangle that's not a right triangle. So we like to get some relations between the sides of just an oblique or a general triangle. So the first one is called the law of sines. So of course every triangle has three sides and three corresponding angles. We'll call the sides A, B, and C. And we'll call the angles opposite these. So we'll call the angle opposite side A, we'll call that alpha. We'll call the angle opposite side B is beta, and the angle opposite side C is gamma. Okay, your book just uses capital letters A, B, and C. I'll use Greek just because it's a little easier for me. But it turns out we have this relation that these of these proportions these fractions are all the same. Sine of alpha divided by A equals the sine of beta divided by B equals the sine of gamma divided by C. So the sine of the angle divided by the length of the side that's opposite that angle is constant. All right, no matter which angle or which side you pick. All right, so there are some very nice consequences to this, but let's just show why this is true. It's not too hard, because these oblique triangles are going to look something like either this, where all the angles are less than 90 degrees, something like this, or we might have something like this, where we have one angle that's bigger than 90 degrees. So we might have an angle that's way out here, or in the other direction. Okay. Well, so why does this work? Well, in the first case, what we can do is we can draw, find the altitude of this triangle. In fact, both cases use the altitude of the triangle like this. Okay, so if we call this H, then we can see that we get two right triangles here, one involving side A and one involving side B. Right. Now we see that if we look at this first right triangle, H is now opposite alpha. So the sine of here's the opposite, here's the hypotenuse. So H divided by B is equal to the sine of alpha. Now at the same time, we have another right triangle here, and this time A is the hypotenuse and H is the opposite. So H over B, or rather H over A, is equal to the sine of beta. Okay, this is the opposite. This is the opposite. This is the hypotenuse. Okay, so we have that H is going to be B times the sine of alpha, but at the same time, it's also going to be A times the sine of beta. Okay. And then just ignoring H now, we can just divide both sides by AB. And then we get the sine of alpha divided by A is equal to the sine of beta divided by B. Okay. Now, when you do that, so that takes care of this part. Okay. The other direction is we could always just take this angle and we can turn it around and put it on, instead of having the side C be horizontal, we could have the side A be horizontal, or this side be horizontal. So you can get, and just do basically the exact same thing. Now, it might be that if you do that, you might get something like this. Well, in that case, it's not terribly different. We still want to take the altitude of the triangle. In this case, it's going to be over here. And now we get we get two right triangles again. We have one here and one here. Okay. Now, if we again call this side H, we can see H is going to be, well, we have the H is the opposite, B is the hypotenuse. And here is our alpha. So we have this. This is our right triangle. So the sine of so H divided by B is the sine of alpha. Okay, now if we look at this triangle here, now A is the hypotenuse again, and H is this. So H over A is going to be the sine of not beta, but what is this? This is going to be this angle plus this angle has to be 180 degrees, right? So this angle right here is going to be 180 degrees minus beta. Okay, so this is going to be the sine of 180 minus beta. Okay, but what is this? Remember, we can use our this is actually going to be equal to the sine of this is actually going to, well, if you use the difference formula, this will be the sine of 180 times the cosine of beta, or actually, why don't we just use the sum? This will be the cosine of minus beta plus the cosine of 180 times the sine of minus beta. Okay, this is, we're just using this, we're treating this as 180 plus negative beta. Okay, so we have this. And then the sine of beta is going to be, this is going to be 0. So this term goes away. And the cosine of beta, this is going to be negative 1, but this is going to be minus sine beta. So this is going to be just, so actually this, when everything's said and done, this is just the sine of beta. Okay. So we get H over A is this. So once again, we have H is going to be the sine of alpha times beta, but it's also going to be equal to the sine of beta times A, and then divide both sides by AB again, and we get the sine of alpha over A equals the sine of beta over B. Okay, so that's how we got that. All right, now you don't necessarily have to do this for an exam, but I just like to, you know, this is such a beautiful result, and you say, where does this come from? Well, this comes from just what we know about right triangles. Okay, so let's look at a few examples. And in these first few examples, what we're going to do is we're going to see, so an angle, a general triangle has 3 sides and 3 angles. We'd like to be in a situation where we're given 3 of those pieces of information, find the other 3 pieces of information. So here we have an angle where alpha is 35 degrees, beta is 70 degrees, and A is 6. Okay. All right, so how would we use the law of sines to find the other 3? Well, first, whenever we're given 2 angles, we know we can find the other angle because they have to add to 180. So gamma is going to be 180 degrees minus 35 degrees minus 70 degrees. Okay. And that will be 75 degrees, I think. Okay. So that's gamma. All right. Now, to find the other 2 sides we have to find are B and C. B is opposite beta, so we can see, and A is opposite alpha. So we know that the sine of 35 degrees divided by 6 is equal to the sine of beta, which is 70 degrees, divided by B. Okay, so now we can cross multiply, and we get B sine of 35 degrees equals 6 times the sine of 70 degrees. Okay, and then divide both sides by the sine of 35. And so So B is going to be 6 times the sine of 70 degrees divided by the sine of 35 degrees. And then making sure that your calculator is in radians mode, or rather in degree mode. This is approximately 9.8. Right. Let's find the other side of C. Similarly, C is opposite gamma, which we know is 75. So we have the sine of 35 degrees divided by 6 is equal to the sine of 75 degrees divided by C. Cross multiplying, we get C sine of 35 degrees equals 6 sine of 75 degrees, and then dividing both sides by sine of 35 degrees. So C is going to be 6 sine of 75 degrees divided by the sine of 35 degrees. And using your calculator, this turns out to be approximately 10.1. Okay. All right. So we found the other 3 pieces of information that we were looking for. Okay, and you can do this anytime you're given 2 angles and a side. You could do this, even if the side given doesn't correspond to the other 2 angles. And that's exactly what happens in example 2. Here C is opposite gamma, but we're not given gamma, but we don't care because we can find gamma easily enough because we have the other 2 angles. So gamma is going to be, again, it's going to be 180 minus 20 minus 35, okay, which is 125 degrees. And so now we have the sine of 125 degrees over 9 is equal to the sine of 20 degrees divided by A. And similarly, the sine of 125 degrees over 9 is equal to the sine of 35 degrees over B. And then from here, doing similar work, we can cross multiply, divide by something, and A, we can see that A is going to be 9 what is it, 9 times the sine of 35. Actually, let's do this. Let's just do all this. So let's cross multiply. So we have A times the sine of 125 is equal to 9 times the sine of 20 degrees. Okay. So A is going to be 9 sine of 20 degrees divided by the sine of 125 degrees. And now you compute on your calculator. This is approximately the 6.3. Okay. And then similarly, B times the sine of 125 degrees is equal to 9 sine of 35. So B is going to be 9 times the sine of 35 degrees over the sine of 125 degrees, which is approximately equal to 3.8. All right. So there you go. We'll look at some other examples in the next video.